All right, these next few slides will hopefully show this in a little bit better detail. All right, this is the ecliptic is the path of the sun on the celestial sphere. Um, oh, actually, you know what? Let me go back one real quick. This is actually really important for us. So you have the ecliptic, right, which of course is the path of the sun. But the thing is that the celestial equator. Okay, so remember the celestial equator is the Earth's equator projected out you know onto this imaginary sphere that surrounds the Earth. Because the Earth is tilted, and we're gonna, we'll look at this in detail in just a moment. The celestial equator and the ecliptic goes above the celestial equator and below the celestial equator. All right, and yeah. So, all right. This is. Oh, and look at this. They mentioned. Uh, Oh, I guess Ophiuchus is the snake charmer. I think before I thought it was some water thing. Anyhow, so they're not even showing you. So Ophiuchus again is right here, right about here. It's you know again um, it's not a, it's not in Ophiuchus as for as much time as it is in these traditional 12 constellations of the zodiac, but it does pass. The ecliptic does pass through Ophiuchus right around here, and for roughly a week or so. So there's actually 12 constellations of the zodiac. All right, I got to remember that Ophiuchus is the snake charmer. I think I said something earlier about a water thing or something. Anyhow, all right. So again, the 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 Earth is tilted with respect to the ecliptic, uh, and so the tilt, by the way, it has been well known for a long time. It's 23 and a half degrees. All right, and there's a reason that we know that you can actually measure it. Even ancient peoples were able to measure this tilt. Um, all right, and we'll get to that in just a second. Um, so when the northern hemisphere is tilted away from the sun, uh, then that would be winter time in the northern hemisphere, like in North America and in Europe, um, and and of course in most of well, I guess it's Eurasia actually. And then when the southern hemisphere is tilted towards the sun, as it is right here, that of course would be at the it's the same time at but that would be summertime, right? That would be summertime in the southern hemisphere, right? So if you lived in Argentina or Chile or Australia or South Africa, that would be your summertime. And it's exactly opposite when the Earth is over here on this side. The tilt doesn't change, but the Earth is over on the other side of the sun. Then the northern hemisphere is tilted towards, and of course for us that's in June and July and August. But June, July, and August, the southern hemisphere is tilted away from the sun, right? So it would be on this side, and we'll see that in just a second. But that would be, of course, winter time, and that is winter time in in South America, in most of South America, in Australia, and most of Africa. All right, all right, so here this shows it very well. There are these 4 times a year. But by the way, they're not. They don't always occur on the 21st, because the Earth, because the Earth does not take exactly 365 days to orbit the sun. It's really 365.24, and even that is not exact. Um, there's actually a few more decimal places involved. So it's right around the 21st. The 21st of December, that's the first day of winter in the northern hemisphere, the first day of summer in the southern hemisphere. Okay, so everybody got that? So that's the first day of summer. So, um, you know, uh, 3 months later, it's roughly March 21st or March 20th. Sometimes it can be as late as March 22nd. Again, depending on the year. And now, the northern hemisphere it's left. It's not winter anymore. It is actually the first day of spring, right? And so, for the southern hemisphere, it's not summer anymore. It's the first day of fall. Okay. 3 months later, it's roughly June 21st. And for us in the northern hemisphere, it's the first day of summer. And in the southern hemisphere, it would be the first day of winter. All right, so 3 months later, notice, of course, the tilt doesn't change, right? That 23.5 degrees does not change. And so 3 months later, it's roughly September 21st. It can be as early as like September 19th again. So on that day in the northern hemisphere, it is the first day of fall, and it's going to be the first day of spring in the southern hemisphere. All right, that's how it works. So the seasons, right? The reason for the seasons is actually because of the Earth's tilt. And it has nothing, by the way, it has nothing to do with, and we're going to talk about this in a little bit. The Earth gets a little closer to the sun and a little further from the sun. That is not the cause of the seasons. It's really this tilt of the Earth. It's 23.5 degree tilt. But by the way, Mars has almost the same tilt and has the same type of seasons. Just to let you know. All right. Yeah. You have these. I was talking about the Earth getting closer and further. And actually, the point when the Earth is actually furthest from the sun is actually, let me see if I can remember it. I think it's right around January 6th each year. So right around January 6th, the Earth is actually a little bit. That's the closest point. Is that what it is? Let's see. That's the closest point that the Earth is to the sun. So 6 months later, it's further from the sun, and of course, in the northern hemisphere, that's summertime. It doesn't matter. It doesn't matter that you're further from the sun, and it's only a little bit further, right? When you talk about miles, right? It's on average we're about 92 million miles from the sun, and so that varies by about 1 million miles, right? So we're about 1 million miles closer and 1 million miles further on, so yeah, I mean, it's not a terribly, it has really nothing to do with the seasons, right? That getting closer to the sun, getting further from the sun, which again it's not very much. You're not varying it that much. I mean, it sounds like a lot, 1 million miles, but you're talking about 92 million miles, so it doesn't vary that much. All right, so this is really what's going on. All right, so if you think about like a beam of sunlight coming into the Earth from the sun, when the Earth is tilted towards, so in this case, the northern hemisphere is tilted towards the sun. So this of course would be, in the months of June, July, and August, you have so it's this, let's say the same beam, the same width, if you will, of sunlight comes in, but it's concentrated over a smaller area. When that same beam, okay, so it's the width of the beam of light, all right, so that's the amount of energy. If you think of it in those terms, that amount of energy is spread over a greater area across the surface of the Earth, because the southern hemisphere is tilted away from the sun. The northern hemisphere is tilted towards the sun, so that beam, that the width of the beam is more concentrated. It's covering a smaller area. In fact, on the first day of summer, it's the smallest area that it's going to be. Which, by the way, you might say, well, why isn't June 21st the hottest day of the year? And you remember, it's usually hotter when you get towards August, and that really has to do more with the weather, right? How the water absorbs energy, right? So it's really the water, the oceans take longer to to heat up, and because they take longer to heat up, the weather, like what the temperature is, starts to really increase. In July and in August. All right. It just takes longer. There's this thing called the heat capacity of the water versus the heat capacity of the land. We're not really going to get into that too much, but that's really why it's actually usually hotter in August than it is in June. All right. All right. So that's it's really this angle and the tilt of the Earth that is caused, the angle that causes it to be hot or to be cold. All right. Good. All right, so the tilt of the Earth and the rotation causes the ecliptic not to be aligned with the equator. We talked about that. This this varies according to what your latitude is. Like for example, if you're on the Earth's equator, you do see the tilt of the Earth. I'm sorry, the tilt of the sun in the sky. But it's much more noticeable when you're either further north or further south away from the equator. Like it's much more noticeable. All right, so let's actually look at that a little bit in detail. Let's see, can we get more information from this? Let's the North Pole. So this is what I was trying to get at. I wanted to show you the pictures actually of this. All right, so this is really what I really wanted to get at is so if you were to just look towards the setting sun, okay, so if the sun sets exactly twice a year, it exactly sets in the direction of west. It almost actually never sets directly towards the west, except for the 2 days, the first day of spring and the first day of fall. Whether you're in the northern or the southern hemisphere, it's always on those 2 days. And so what happens, of course, is it depends on where you are on the Earth. But if it's winter for you, the sun is setting as far south on the first day of winter. It's as far south of west as it's going to get, and the first day of summer, it's setting. We're talking about the setting sun. It works for rising too. It's setting as far north of west as it's ever going to get. All right, so that's what takes place, right? If you just looked at the setting sun and you measure this